Right.
Mm-hmm.
See the periodic table here, and usually when we were in high school, we already learned about the chemical substance. Here you see there are a group A in this side and the group. So what do they mean? They mean that in group B, it's kind of the transitions metal. Okay.
Mm-hmm.
On the other hand, all right, the group A uh, is more likely ferri. Okay, from the
What? Fierai? What?
ferry. Sorry.
Fairy?
Yeah, the ferry. I mean, the differs. Group A is more differs because
Diverse.
yeah, differs in group 1A. You see, it's the alkali metal. In 2A, there is alkaline earth. Yes, alkaline earth. I could say that it's also metal too. And in the group 3A, 4A, 5A, 6A, 7A, no 7A. I mean from the 3 up to 6A, um, they are also very or differs. As you can see, the color orange indicates the basic metals. It consists of aluminum, gallium, indium tins, okay, thallium, lead, or timbal in Indonesian, all right, and etc. In the color green, it indicates the semi-metals like borium, silicons, germanium, arsenic. Arsenic is so toxic, man. I learned that in safety concerns, the long exposure of arsenic will make you to have cancer. And then the antimony, etc. And then on the other side, we have non-metals that is presented by the blue color, like carbons, nitrogens, oxygens, phosphorus, sulfur, and seleniums. They are what Rendia think, it could be organic. So Rendia, the carbon, nitrogen, and oxygens, and
It's
hydrogen.
organic.
Yeah, they are organic, man. They're
Okay.
organic. So
Because
any compound that contains this kind of substances, they are organic.
it's
And next we have the 7A. It is special, man, because we are told that it's gas and the atomic. It's the meanings that all the substance should be in a pair. Like fluoro should be like this, chlor chlorine like this, bromine like this. It's called as a noble gas. Sorry, not noble gas. Halogen. Yeah, halogen substances. All right. The most special thing is the the end of the it is called as a noble gas.
mm,
Yeah. It is because the the electrons are so stable in these substances. Okay, all the substance actually want to be as similar as the noble gas. So they the other substance are looking for the most stable condition like what noble gas does. All right. First of all, I will likely to talk about the rules of the redox. You see that in number one, when it comes to the free substance like hydrogens, zinc, uh, manganese, and the sodium, if the component is like this, you simply just write O or zero. But if it's a hydrogen, just add plus one for the number or the oxidation state. And the oxygens, you see, when it comes to oxygens, it's gonna be -2, but when it comes to peroxides and superoxidates, they are respectively -1 and minus a half. And then the number four, you see the the oxidation state of natural compounds, like nitrogens and ferro. Said you just have to write zero. You see in the number five, the oxidant state of charged compounds. Okay, the compound that is charged like you know they have it has -2. Okay, so the oxidation number or oxidation state would be -2. Depends on its own charge. It is said.
Hmm.
And number six, you see, when it comes to the category of ion of oxidation states, like sulfate. Sulfate contains the -2, so it would be -2 too.
Why is it
Wait,
two
yeah,
minus?
yeah, two minus. That's right.
Okay, so it is ion actually. It is ion like sorry, for example, like NO3,
Yeah,
like
You know what, Ran? We should have know about this because we took chemistry class when we were in high
beforehand.
school.
Yeah, yeah, I know.
Kind of weird. We don't.
Okay,
We,
sorry.
yeah.
Is the -2 and two minus are the same, or is it different? Kind of forgot there.
So you are confused about the difference between -2 and
Two
2 minus.
minus. Yeah.
Okay, when it comes to the ion's normal writing, you see, you should uh write like this, 2 minus, or for example, like ferro 3 plus. So it would be better if you write on the number first and the indication after.
Okay.
All right. So
so all right. So
this
all right. So it tells you that it is an ion if the minus or the plus science is in the left side, in the right side
right
of the
right
number.
and sides, yes.
If it is in
It
the left
indicates that
side,
it's ion.
if it is in the left side, it is a charged compound.
Yeah, I will give the example for better
All right.
understanding
All right. All right.
afterwards. Yeah, and then the seven, you got the several groups of group A. All right. So when it comes to the first A, you see there are components like lithium, sodium, kalium. Sorry, not kalium. In English, you say potassium, RbCsFr. The oxidation state or Redox should be plus ones, and the second A, you see the example beryllium, magnesium, calcium, and selenium. You should put +2 for the oxidation state or Redox, and the group 3 of A, like aluminum, simply you just put the +3. So next for the fourth A, like sulfur oxygens, you simply just put -2. Lastly, we have 7A, like fluoro, uh, chlorines,
Fluorine,
yes,
fluorine,
fluorines,
bromine.
bromines, and iodines, or chlorines. You simply just put -1.
All right.
And I will likely uh, give you some examples. Or
So
wait.
these rules, are important to
This rule,
understand.
yes, yes, it is really important for the electrochemistry stuff. This exercise will teach you how you can
Oh,
use the oxidation
all
number
right, all
or
right,
oxidation
sure.
stats. Yes, like this. Determine the sodium, uh, nitrate, and then J2O4, and the ferro or the irons with the ion +3, nitrogens and manganese. All right.
we have to determine the Bilox,
The
Yeah,
oxidation
Bilox.
state, right?
Bilox. Yeah,
the oxidation state.
the oxidation step.
All
So
right.
you
So
see, oxygen. Oxygen. You see the first in here. It should be -2 because
-2.
yeah, -2. We have the rules that tells in group 6A should be -2 in oxidation step. Yeah, and then you can uh, you know you can multiply the -2 with the amount sorry, with the numbers of oxygen, so it should be -6.
-6.
minus
Yes.
6 And then nitrogen we have let's say we should look at the table first.
Oh, plus
Yeah,
5.
is there any nitrogen here?
Uh,
I think in the
in the periodic table, it should be next to oxygen. So basically, plus, yeah,
Oh, here. Oh,
yeah.
5A. 5A, right? Okay, we see
So in minus
it.
minus three.
Unfortunately,
wait,
we don't have
minus.
the rules of the nitrogen, so we can skip it. All
So
right.
plus 1. And A is
We still don't know what's the Bilox of nitrogen, so we jump to the sodium instead.
plus
Okay.
So
1.
we should look at the table first. Okay, we see we have actually in the first A. It should be +1. So simply we can put +1 here. Okay. So the rules is that the 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 total numbers of the B log should be in result of 0. On so the conclusions, the nitrogen will be 5
Oh
because
yeah.
the 6 and the -6 will result in the 0.
The end result should be 0.
Yes, yes, you are very true. You are very true.
I see, I see, I see. I get it.
Yeah.
Wait, hold on.
So the whole compound is zero basically, in neutral, right?
Yes, the whole B logs, the total B log should be 0 when it when you do what penjumlahan man?
Adding
Some,
Calculation ya? Sum.
some.
Okay, when you sum all the numbers here on the upper side, it should be 0. Like this, for example, like -2.
It should be -8 total.
Yes, it should be -8. All right,
So it will be plus 8.
+8 here,
So
and
each
then
is +4.
+4. Yes,
Oh yeah,
so
yeah, yeah. I
plus
get it.
8 plus -8 should be 0. But on the other hand, each of carbons would have +4 and the oxygens would be -2. Next, we have ferro +3. All right, it's kind of iron, right? Okay, we see when it comes to ions, we have the number 5, the oxidation state of charged compounds. All right, it depends on its own charge. So we see again. All right, the ferro has the +3, so it would be +3.
Okay, got it.
Okay, so Ferro is +3, just +3.
Yes, just +3. I
Oh,
mean,
just plus
it's
three.
actually mistake, man. Not Fa +3. Actually, it is Fa3+.
3 plus because this is an ion.
Yeah, it is.
Oh, because it is an ion
It's not a compound.
charged compound.
Okay. What about this? Manganese. Manganese
How
should
about
be 0.
nitrogen?
It's zero, right?
We
Yes,
don't
because
discuss
we
it.
have in the number 4
Oh yeah,
It's a
zero, zero.
unnatural
substance.
compound.
So that's why we skip it.
Yeah, we can just simply put 0 for the Bilox.
All right,
Next,
all right.
what about it? Determine the reaction on oxidations for these reactions. You see, First we should determine the blocks. Beforehand, I would like to erase the mistake first. Okay.
So we use oxygen first, right? Since we know oxygen is just 2 minus minus 2, and
Yes.
then magnesium should be plus 2, right?
Plus
And
two. Right. You
and
see.
basically the Mg in the resulting reaction should be plus 2, 2 plus,
In here.
yeah, 2 plus, right?
Uh,
Plus two, two
plus
plus,
two.
plus
Plus two,
two,
right?
man, because it
Okay.
isn't an
Oh,
ion.
oh yeah, sorry. Yeah, it's a plus 2, and then
Okay.
the two always will be 0, but each one will be plus 2, and yeah, the what is
So
2
it
is?
is zero.
Is it 0?
Actually like this. You see,
It's not 0,
Cu
right?
is actually zero because it's classified as the uh
Free
number four.
substance.
Yeah, free substance.
Oh, you see.
Then mangan should be zero too.
Yeah, then mangan should be zero too. It's free
Oh,
substance.
all right, all right, all right.
Okay, okay.
Free substance.
Yes. So yeah, we should revise the
Oh,
uh
it's not plus
for
2.
both magnesiums. It is magnesium actually, not mangan, man.
Oh, okay.
Oh yeah, yeah, that's
Not
right.
plus.
It is magnesium. Sorry, sorry, sorry.
Yeah, for mangan it should be Mn. All right. So we see that the Bilox is revised to zero.
Oh, and the
And
Q now plus 2.
the
I see.
cuprum oxides should be minus two and plus two.
Wait, is that? Oh yeah. All right, I get it.
Cuprum, mercury, right?
What is
Oh,
cuprum, man?
is it mercury?
Uh, it is actually
A copper?
cuprum. Let's see, cuprum. Cu.
See you.
Here.
What?
It's,
Where?
it's
Cuprum is copper. Cuprum is the Latin, but the
tem-
copper is in English terms,
yeah,
meaning
Oh,
it's tembaga in Indonesian.
yes,
yeah, yeah,
it is
copper.
what is mined in Freeport McMoran
What?
in
Freeport?
Papua.
What? Oh, this this cuprum stuff is mined in Freeport, Papua.
Yeah, as the
Oh,
second product beside the gold, or
oh, I see. I get it. I
uh,
get it.
what is gold, man?
What? Gold? What?
Yeah, what is the substance of gold?
Oh, it is. Um.
AU.
Yes, AU. You are
Oh,
very
au. Yeah, yeah, yeah. AU.
aurum. Yeah, but the
Aurum.
English form is gold.
Au.
Yes,
Au. In
au,
Indonesia, it's quite funny. What is gold in Indonesia? Au.
au. Yes, and okay, jump to the our reactions. Okay,
Good enough. Okay. What the hell?
All right. Uh. All right.
all right. I will give the arrow for the reductions. Okay, the reduction should be like this. When it comes to Mg,
Magnesium.
all right, it should be reductions.
Ah,
Oh.
Why? Because
Oh.
you see, reduction rules, reduction rules. When the oxidation state is decreased, like this, it's decreased from plus two to zero.
Yeah, yeah, yeah. That's right.
Yeah, as the oxidation state is decreased, then it should be called as reductions. On the other hand,
Wait.
you see,
That oxygen is not plus two. It should be minus two.
oh yeah, the
That
oxygen
oxygen
oh,
on
okay,
from
the
the
left
okay,
side,
cuprum.
yes,
on the
yes.
right side.
All right, it's minus two actually. All right, but and the copper, it's already true because
Yeah, yeah. That's right.
uh,
Yeah, yeah.
the plus two and minus two will result in neutral. on the other hand, the copper.
The
When it comes
copper
to
is
copper, yes, um, it should
oxidation.
be oxidation. Yeah, you are very true, Randy. Why? Because
The
the
number.
oxidation state is increased here. Oxidation. All right. Jump to the next.
Oh,
Another
what?
exercise. Yeah. Determine the oxidation states of each the substance that is underlined.
All right, I'll go first.
All right. Okay. Let's see. K2SO4. How did you
Minus
search it?
eight, minus eight of O4
Minus eight.
oxygen,
All right.
and it should be. I think K is plus one, so it should be plus two. I don't know. I'm not sure.
Okay. Okay. Plus two, and then
Okay, of course. Sulfur would be minus. No, no, plus six.
plus six. All right. Let me check. It's actually true, man. You
Oh,
see?
it is true. Yeah,
Yes.
I'm kind of using my intuition about
Intuitions.
that K. It should be one. Yeah, just using my intuition about
Yes, it's
that.
true. It's true.
K.
The answer, yeah, you are very true. It is because you see, when you calculate the Belox or the oxidation stats, the S would have plus six.
Oh, sulfur always plus six.
Uh, Actually, I'm not sure. It depends on uh, the compounds, the compound first. But on the other hand, the oxygen is fixedly minus two.
Oh yeah,
But
that's true.
when you
Four.
multiply it for four, it would be minus eight.
Yeah, yeah,
Okay.
yeah.
And what about the number two?
Andra, Randia, Randia.
First of all, let me check again the table. I don't know the
No,
the
We don't need to check the table, I think,
Oh yeah,
because
yeah, yeah. All right.
oh yeah,
really
but up to you. I mean, it should be quite up. Yeah, up to you.
it
So,
doesn't exist though. All right, the CR. Next one, next one. There's nothing there, but okay, got it. So basically, all seven will be minus, let's say minus 14, right? And then the
Okay, hold on, hold on. I will write it first.
CR2 with all seven with minus two minus. Okay, so the oxygen should be minus 14. Oh yeah, we don't really need to check the table because it's just all right. So basically, how much how if we sum the CR2 with the oxygen, it should result minus 2. So basically, what happened is the CR2 must be minus 12, and then we divide it by 2, so it was this the chromium should be minus 6 plus 6, sorry, plus 6.
Plus six.
The yeah, this chromium upper 2 is actually is also plus 12
All
right
right.
then.
Are you sure about it?
I don't think Randia is right about that
Okay,
CR.
got it. Got sorry. What happens?
Yeah, actually, it is true. Plus
It
six.
should be plus 12, man.
Yeah, it's actually plus 12, not minus 12.
Yeah, it is because when you calculate plus 12 and minus 14, it would result in minus two.
Hmm.
Yeah,
Yeah.
yeah,
So it is the charge, man. Charge.
yeah.
Oh, it's not an iron or what?
Well, I think it is because it's already the compounds.
Oh, I get
The
it. I
ion
get it.
on the other hand is like this. So uh,
Is it not a
actually,
compound too?
yeah, actually, when I was in the middle school, the teacher actually give me some uh the polyatom. Okay, polyatom. So the polyatom is like this. We have carbonate like this, two minus, and like this, phosphate. So it is called as the ion.
Hmm. Hmm. I see. I get it.
So this is an ion, right? Basically, the Cr2O7.
Uh, yeah, it might be ion, maybe. Yes. Okay. Next.
What is
Uh,
this? Okay.
determine the oxidator, reductor, oxidation result, and the reduction result.
Oh my God. Plus 6. Sorry, minus 6. So the
Okay, so we got -6, right?
yeah, the FA should be minus 6. Sorry, the FA will be plus 3, right? The ferrorium.
+3 here.
No, the yeah, the each of the atoms element plus 3, and then the 3CO should be minus 2. This carbon should be plus 2. Sorry,
Carbon +2.
yeah, plus 2. And then after the certain and it must be 0, right?
Yes,
Because they
okay.
are,
All
and
right.
the CO is
Oh, it,
Wait,
okay.
CO what?
It's
Yeah. Oh, yeah, yeah. I get it.
segment. Oh,
All right,
excessive
no
carbon
problem, no
dioxide.
problem.
so it should be minus 4, plus 4, sorry, minus 4, plus 4, and then plus 4. Yeah.
Okay,
So
okay, okay. Let me rewrite what you already say. Okay, so we have
so FA should be reductor. Hey, what do you mean by reductor?
okay. Wait. All right. Nah. As okay. For example, ferro is ferro reductions or oxidation?
Should be reduction because it decrease the oxidation
It
state.
decreases. Yeah.
Yeah. You are very true. The other hand, the carbon.
Well, oxidator.
Yeah, it's actually oxidations, man.
Oxidation.
That's for.
What is
But we okay, but we still haven't answered the oxidator and reductor yet.
yeah? I figured out if you want to call things a oxidator, is basically the things that have reduction. Is it true, Andre? Is that
Yeah,
what happens? Okay,
yeah, you
got
are
it.
true
Yeah,
because
it's the opposite.
the thing that experience the uh, reductions will be the oxidator as it makes the other components to be oxidized. For example, like oxidator of um, here ferro oxide. All right. While it experiences the reductions, it makes the other compound to be oxidized, like carbon monoxide. So the oxidator,
Should
the
be
oxidator is
ferro.
FeO3. Yes.
Oh, so wait, what?
It's kind,
So,
the oxidator is
Oh,
is the thing that oxidate the other thing basically.
yeah,
oh,
you are
so
true.
Mm.
if it, if it it if it redux, if terjadi, if
Happen,
Happen,
it,
happen, occur.
yeah,
occur.
if reduction occurred, then the right no the left compound element is an oxidator, and if it is an oxidation, the left element is the reductor.
Yes, you are very true.
Oh,
Yeah.
I guess I get it. I get it.
Yeah, you are true, Adil.
Yeah, I get it. I get it. Oh,
Okay, we have finished to write it. Next, about the oxidation results and the reduction results. What are they?
Should be the oxidation result should be the 3CO2, right?
Yes.
And the reduction should be
So
2FA
2FA
Wait,
for reduction
for
result.
reduction result.
Yes.
wait, hold on, Ren. Did you change the title of this podcast?
Oh shit, I
I
forgot.
still a clever security mechanism.
Oh god, sorry. I forgot to put the title in there.
Oh, so you forgot to rename it.
Yeah, later
Yeah, I
actually.
think I will rename it. No, I don't know. Can I?
Can I?
No, no, no. I don't know if it's already
Yeah, I could not.
berlangsung, if already live. I don't
Maybe
know.
after
Yeah,
the.
yeah. I think it will be me who.
Sorry about that. I
No,
don't. I just
no
start
problem.
streaming without thinking.
Yeah, no problem, no problem. It
Right.
happens. It already happens. Yeah, yeah. Go on, go on. I'm sorry if I interrupt.
Got it. Okay.
Wait,
We
we are
done?
done.
Actually, I wanna, you know, add some the additional
Oh, sure, sure. Go
material for.
ahead. Go ahead.
Okay. About the metal oxidation state.
Okay.
Okay. The first thing you need to know about metal, uh, it would be always plus,
Always.
always plus.
Oh,
For
always
example, like this.
Are we talking about
Huh?
the transitive metal or
every medal.
every metal?
Uh, Actually, it is mixed between
Oh,
the
it's not.
transition metal and the group A metal.
Oh
Mm,
yeah.
Okay, for example, like this. Please, it is like a, the name rules. So how you can name a compound like this, for example, Fa2O3. How can you name it? All right. The first thing is that you need to put the oxidations that are Redox. So here, Fa2O3. You see, we have -2 for oxygens, multiply it for 3, results in -6. And here we got +6 or +3 when it's divided. All right. So you see, because the ferro has the +3 for the Velox, so simply we can call it iron 3 like this, and oxide. Yeah, it's
All
easy.
right. All right.
Yes, something like that. All right. The uh another example, SN SnCl4.
Cl is
What does it mean?
chlorine.
Yes, chlorine. You see, chlorine from the table.
Oh, it will be -1.
Yeah, you are very true.
Chlorine. I see. Sn is what is Sn?
And actually, the metal that we are looking for.
No, I mean the name.
Uh, Sn means pin,
What?
pin. Uh, Let me search for you.
Element.
SN.
Oh, stannum. Stannum.
Uh, where is that? Oh, here.
Stannum. It is a tin. Yeah, yeah, tin.
Anum, yes.
Oh yeah, stannum.
In Indonesian, it's timah actually.
Yeah. Well, I've just know it that timah in English is tin.
Oh, you just know it?
Yeah, I just know it because I have no idea. I have no business with element stuff, with chemical stuff.
Yeah, it could be like this.
All right, all right.
Tin for chloride, simply.
Stannum, stannum. All right, go on, go on.
Okay. What about
Oh,
plumbum sulfur coat?
oh plumbum,
Sulfate. Yeah, plumbum.
sulfate, sulfate,
Yeah.
oxygen.
Remember that's SO4 is actually 2 minus.
Oh, it should be plus two. Boom boom is plus two, right?
So it could be like this. As SO4 is already ions, so it would be minus 2 and plus 2 here for plum boom, and plum boom would be plus 2 for the Bilox. So uh, the name is lead plus, no, 2, yes, and sulfate.
Why do we need that two stuff?
2 here.
Yeah. What makes we need that?
Yeah, because it is the naming way of the
Oh, I see. Naming convention.
yeah, naming conventions.
I
Is it
see. I
because
see.
it plus four? Is it not because of the oxidation state?
Yeah, it is because of oxidation states that we should name it for
Oh, I see.
from here.
So yeah, so tin four means it has oxidation state of four in the tin from the compound. Okay.
Yeah. Andra, what is lit in Indonesia?
Lead is timbal.
Oh, timbal.
So lead is usually uh, available in uh, oyster
Oyster
in
is
laut.
oh, kerang laut.
Yeah,
I
yes.
see. Wait, isn't lead is dangerous for our health?
Yeah, it's
So
dangerous.
eating
And it's
oyster is
already in ikan sapu-sapu.
so oyster and ikan sapu-sapu is are bad for our health.
Yeah, are
Oh,
bad for our meal, man. I mean, we should rarely eat those meals. Like, don't make you often consume the oyster or kerang laut for you know frequently, because it will
yeah.
make you sick.
But if we live in,
And then when you have the higher level of your lead into your body, then it will affect your own health. You may get some cancer, Tim.
yeah, yeah. I mean, there is this story about car, right? In the past, they used lead as their oil, and it turns out it makes so many people unhealthy. That's what I watch from Veritasium channel.
Oh, all right. So you mean it is cooking oil?
King oil?
No, oil for cars
Oh,
and
cars. Oh, okay, okay.
right, Adil?
Yeah,
Cars?
yeah. That's
Yeah.
right. That's right.
I don't see why too, but I
Yeah.
know lead is dangerous to touch. It's kind of toxic even to touch it. So
Yes.
yeah.
Maybe
And
all.
if
Yes.
you talking about toxic, you should talk about asbestos, which still used in Indonesia as a building material. It
Yeah,
is,
yeah,
Oh,
yeah.
yeah,
It contains the arsenic
yeah.
or
It contains asbestos. Asbest is just asbestos.
no, asbestos is different than arsenic.
Yeah, I think asbestos is different than arsenic. But what I
Oh,
mean is asbestos is just
oh, okay, okay.
toxic too, basically, but still used as a building material in Indonesian halls and so. But yeah, that's what I think. But
Oh, okay. Let's see. What does asbestos contains?
is it just asbestos an element?
I don't know.
Uh,
No,
okay. I mean,
I could check it though, but still streaming. Okay.
all right. Asbestos here means to substance. Okay, that contains the silicon mineral, silicate mineral.
Oh, it's not okay. So it's
So
an
it's not
element.
arsenic.
Hmm.
Yeah, there's this chemical formula that I see right now. I'm going to paste it on the chat. Yeah, that's the
Oh, asbestos
Oh
material
yeah, yeah,
compound. All right, got it, got it, got it.
yeah. Yeah, it's kind of a complex chemical component.
Hmm.
But the uh, what is the movement?
The
Oh,
debris,
dash,
the
dash.
debris,
The dust
the
that is
debris. Okay, the
produced
dust.
from the asbestos would harms your aunt's lung, as it's quite little and uh, uh, sharp.
What
Okay.
It's
sharp? What
little. It's
sharp?
sharp. Yeah, sharp.
Oh,
I mean,
sharp.
microscopic level, it is sharp and could, if it inhaled, it could
When you
irrit
inhale it, yeah, it could harm
give,
your own lung.
yeah,
Yes,
Oh,
irritate
harm.
your
manometer,
lung, something like
I
that.
see.
something
Do
like that.
you ever experience it before? Have you experienced it before?
No.
Actually, I haven't experienced it yet before, but
Uh,
I already learned about the danger of asbestos exposure. When it comes to the asbestos productions, the dust would be inhaled by the workers, and the workers in the long runs uh, you know, get sick
yeah,
and
that's right.
sick because of the long-term exposure.
Right.
So the preventive actions we should, let workers to use the mask.
Hmm.
Oh, use
Yeah.
mask. I see.
Okay, and then next, when we start about how to uh, write the formula from the name. For example, like chrome oxide.
Okay.
All right. First of all, Andrea, here we are talking about metals characteristics, right?
Yeah, we're talking about the metal characteristic,
Oh, I
uh,
see.
oxidation state.
All right. All right.
Means it
Okay.
is the last material that I will give you,
All
as
right.
the times is up.
No
Okay,
problem. No problem.
it's simply because when you wanna give the formula from this, just make it quick. So you see, Cr and the oxide. All right. Um, so the three plus you can put on this di atas itu, di atas apa namanya, tempat kunci itu nggak ada.
We have interruption going on.
Yeah,
Yeah,
Andrea, I think you should
there's
mute.
an instructions from my sister to
Okay.
look for the car's key.
No
And
problem. No problem.
yeah, it is 2 minutes, and yeah, just make it quick. Sorry.
Wait,
Ooh,
why did you make a cross sign?
yeah, make cross as. Sebentar. Sebentar.
Andrea, you should mute it because we are in live streaming.
All right. It's fine.
Uh, Now it's going well. So,
Mm.
Randia,
Yeah.
please uh, continue, Andrea.
I think I know what he wants to do. Like basically, chromium. When you hear like chromium 3 with oxide, which basically chromium has a 3 plus, right? So to create when you have this metal with oxide things, you basically just cross it. Like you have this oxidation state which you can cross each other. So the chromium, given the oxygen is -2, is basically to make it neutral. The chromium should be basically like multiply by the oxygen oxidation state. So chromium having C see that the oxidation state is 2, and its own oxidation state is 3 plus, and the oxygen is -2. Basically, you want to make sure that it's become neutral by multiplying. So the chromium times 2 is actually +6, and the oxygens times 3 equals -6, right?
Oh, so
So
in the end, the sum is zero.
yeah, the sum is zero. So basically,
Oh,
what happens is the chromium is Cr2 and the oxygen is 3. Basically, has a
oh yeah,
3 in
yeah.
the number.
I understand. I understand. All right,
Yeah, you are
Andra is
very true.
online again.
Like,
Okay. Lastly, I will make it quick. For
No
example, like
problem. Take your time.
take your time.
copper,
Uprum.
Cuprum.
copper, two nitrate.
Oh,
G
Cu nitrate.
NO3.
Or NO3. Oh,
Okay. How does it called?
Basically, the NO3 should be there are two NO3, and the cuprum should be just one.
oh, wait,
Complete.
what? Oh,
Big brain.
oh,
Because copper has plus two belocks, and
oh, I get it.
it just has uh minus one here.
Oh, yeah, I get it. Oh, yeah, yeah, yeah,
So
yeah.
in this
Understand,
case, you
understand.
should cross it plus two here and minus here. I mean, one here. Yeah,
Oh,
something.
yeah, 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 yeah. Understand, I understand.
Yeah, I mean, I
Oh,
think it's enough for me
all
to
right. That's fine.
talk about the redox. And sorry for the interruptions that just
Yeah.
occurred.
That's fine. Cool.
Yeah, so
I'm
uh, the intention to learn it to understand more about the how battery works later, since it's just basic.
All right. So you mean that the reason why we try to understand about redox is because in the next session, in your next session, we are going to discuss about battery.
Yeah. You are very true.
Oh, I see. That's why. All right. So redox, huh? I think we had learned it when we were a 12th grader, I believe.
From 10 for
Wait,
hours.
from 10th?
depends on the curriculum though, but
No, we should be the same.
no, you used
Kurtilas,
20. Yeah, I and Andrea used
SP.
26
Oh, you use
2006.
26.
2006,
Oh, yeah, 2006.
The last
Well,
batch that learned
the last batch.
about KTSP.
oh, I see. While I use 2013 curriculum.
Oh, okay. So,
So we were different, I guess.
Yeah.
oh, okay.
Yeah.
Yeah, so many presentations, right, to be held.
No, I think. Oh, hold on. E... Wait, is it? Was it? Yeah, we are talking about chemists, right? Yeah, that's right. Yeah, I kind of forgot about chemistry. Yeah, yeah, yeah. No. There weren't any presentation. At least very few presentation back then. If it is chemistry class, so that's it.
Okay,
Yeah.
okay. Yeah, yeah.
So we, all right, and we are going to use it for battery. I mean, wait, Andrew, do you know that on when we are into chemistry industry, will we use this redox stuff, or is it just when we are into research, into academic stuff that we try to use this chemical redox calculation and stuff? Just wondering.
Actually, yes, you are very true. The oxidation hits is used for, uh, you know, the theory or the research of the battery components. As when you hold the battery and how it works, it would have some chemical reactions. So the chemical reactions could be routed from this oxidation state components uh, scheme. This is why you need to understand the Belox or oxidation state first before you jump into the chemical reactions of the electrochemical components to make you easily understand.
All right, all right,
Yeah.
all right. No offense, Andra. Just wondering. All right, just wondering.
Okay. Yeah.
Have you ever went to an internship in chemistry, or are there such course in your school right now?
Actually, we we don't have the Redox curriculum anymore, or we don't learn about redox or electrochemical stuff anymore. As actually, it is for the pure chemistry instead of chemical engineering.
All right.
So
So,
before I review about this, listen, already learns from my own first.
oh, from your own.
Yeah.
So you mean this redox stuff you didn't your teachers in your school didn't uh don't don't teach
when
this
it's
anymore?
when in the previous college when I was in chemical analysis, we learn again about it. But now when I converted to chemical engineering, I don't learn about the electrochemical stuff anymore, as we'd rather be focused on the engineering sides of the chemical processing.
Oh, I see.
But
And
sure, when you want to know about the battery, I mean, it would be beneficial to understand why the reaction like this, why it should be like
oh,
this. It is
yeah, yeah,
because of
yeah.
the numbers of oxidations and how electrons could be removed from cathode or anodes, something like that.
Oh, I get it. I get it. I get it. So, Randia, do you have any question?
Yeah, I will
Nah.
send the paper for India.
Oh, thank you.
Oh,
Yeah. But no, I think I kind of got it. This is Redox is actually like I thought uh okay, maybe we just one question for Andra. Like, redox is pretty much the basics, right? On in the chemistry, like, for us, Adil is kind of like akin to learning if and else in programming. You don't really learn it after in the very advanced course, right? But it's still used, uh, of course, in the programming side. But you don't learn it more, but you just use it in the advanced course. So is it like that, Andra? Like if you already learn Redox, you don't really learn it again. You just use it as a tools perhaps to understand the oxidation
Yeah,
uh,
yeah, you are very true.
on what happened next
What
in the
happens in electrolysis or
yeah
voltaic
yeah
cell?
something like that.
Yeah, yeah.
Hmm.
I mean, I wanna review again about the fault like and electrolysis. Actually, from what I already learned, that actually we should learn about fault like first.
Oh, I see.
for what
Electrolysis.
voltage?
Fault like, yes, fault like. It is how the electrons flows naturally.
Oh,
So when it comes to electrolysis, it's the electron flows unnaturally, meaning we pull the electrons back, okay, to the previous electrode.
so this voltage, yeah, pull electron from one place to this to
Yeah, it is
the
how the electrolysis works. But in voltaic, the electrons flows naturally, meaning it will produce the electricity power.
produces electricity power.
Yeah,
Oh, yeah,
from
power.
the electron move, I
Hmm.
think. Yes.
Yeah,
So
kind of like
basically, electricity is electron, right?
yeah.
So, what will we discuss in your next session, Andrea? Will it be voltage
Well,
or
maybe it's gonna be no, no. I mean, I will make it transitions to be the a half reactions of the uh, redox reaction.
Oh, redox again.
Yeah, but it's gonna be more complicated, I think.
More harder. Randia must love it.
I hope so.
Yeah, there are some
I know.
chemical reactions that will be complicated,
Oh,
but
I see.
yeah, I will make it easy to understand, I think.
Uh,
Understand how, yeah, you can calculate the voltage of each the cell once you understand this, like you can calculate the cathode voltage and the anode voltage, and it becomes the total voltage that will be resulted in in the end from your battery. So yeah, I mean, yeah, it's gonna be useful to learn.
Mm.
all right, all right, all right. That's really, really, yeah. I mean, that's quite. How do I say it? Yeah, quite. Yeah, yeah. That's really cool. I guess. So cannot wait to learn more.
Yeah, yeah.
Right.
So I guess, Randia, do you have any question again?
Nah, I'm good.
All right. So am I. So I think we are in our end, and back then we were discussing about Redox. It is how to use it, the calculation behind it, and well, we are going to discuss it more in Andra's next session, which is in 3 weeks ago.
Yeah, battery series.
Yeah, this a series of, yeah, mine is also a series, about negotiation, listening, and stuff. That's fine. So yeah, thank you so much for watching, and see you again next week. Salam.